Monitor? All right. Share my screen now. Remember to do that because last time I forgot. Um, so we talked about the initial setup of it, the Reduxy kind of structure, the relationship between the container, the store, and how that interfaces with the person, the user who's going to be using the component. The mega component that is the menu container that is basically responsible for translating whatever it is that you have provided the dropdown, be it the items and all the various properties, how that renders out. Talking about the renderer, which is something that is responsible for showing highlighted items and going up and down, scrolling, and all that kind of stuff, that runs outside of the React render cycle. It's using vanilla JavaScript to do all this kind of stuff. And the reason for that is purely for performance. Um, so dropdowns can get quite sluggish if you have a lot of items or if your dropdowns are nested, like this example here. I press left, down, 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 down. Sorry, right, down, 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 and so on. Um, and that is because for every single one of these items, you can think of them as nodes. Um, if you were to have coded this in the more traditional React sense, that is the declarative, very simple sense, um, React would have to iterate over every single one of these items for every single movement that the user does, be it mouse over or keyboard up down, whatever it is, and render accordingly. And there are a lot of things bound to these items, like these hover events and so on, and also position calculating, and the ability for the items to render custom UI, like so. So these items can get quite complex, and coordinating all that with the dropdown and also having n number of items nested n levels deep gets quite heavy. So having something that's vanilla JavaScript, very low level, calculating how to render, parse, and interact with the UI, it's way more performant, and that's why we do that. Ideally, I wouldn't have to write this essentially render engine thingy for the dropdown, and I can just use React to handle it. And I've tried so many attempts at just doing the React route, not route, but the React way of doing it, but the performance just wasn't there. I've examined multiple libraries, multiple implementations, including React Select, React Select 2, Downshift, which is a very popular, very low-level primitive that you can use to create a combo box, created by Kenzie Dots, and I think is I thought it was under PayPal. Now it's Downshift JS. Very extensive, very cool library, and something I used as an inspiration for the build of Dropdown V2. So now we're going to continue talking about Dropdown V2. I think I'm going to wrap up everything in this one, talking about the actual menu UI, the items, the concept of groups, like this, nesting, and then also, hang on, nesting, the state reducer, and then also how to extend dropdown to create other UI, like, for example, a combo box, like so. So the dropdown within HSDS React is for better or for a lower level component, even though it is absurdly complex. It is just like an input or anything like that. It's a lower level component that you would use to create other components like a combo box or various other types of drop downs and so on. Um, it provides you with all the little bits that you need to create a drop down with full keyboard support and so on, accessibility and so on like that. Um, so that it's very easy to use it out of the box. By default, you just instantiate the drop down component and give it some items, and then it can render a full drop down for you. Or down to the level of you can render things using a render prop and then render literally whatever it is you want, which allows me to render something that looks like this. Gorgeous. Oh, and the other things about dropdown is that they are directionally aware. So if I drag this and it's about to get cut off, it'll then drop up instead or do that. And I think that's the only kind of directional awareness built into dropdown. Um, I don't think there's left and right awareness just because that is also, yeah, there is no left and right awareness. That is too complicated. Um, okay, so that's a good starting point, directional awareness. So inside of HSDS React, we use a very popular, basically go-to library for kind of directional based positioning of UI, typically found in something like tooltips and modals. No, tooltips and popover, sorry, popper.js. And I think this is the go-to library that most folks use, including folks like Bootstrap. This is really cool because here you can drag and then you can see it follow and move, which is really nice. And it takes care of all the math for you to figure that out. But for Dropdown v2 and just dropdowns in general, we can't use Popper because Popper only takes in consideration something that isn't nested. And by that, I mean something that doesn't kind of expand after the fact. So if we have a nested dropdown, be this one, right? So we have one single box that drops down, which is fine. But as the box continues to expand, like this, the width, let's see if I can enable this. Yes, no, it doesn't work. The size of that box also expands. So if I had something like Popper, it would take the entire thing into consideration, and then it would skew the math in ways that is unpredictable. I've experimented with this several times. Maybe my implementation of it was incorrect. Maybe I can try again. I'm not sure. But in the meantime, I wrote a kind of a primitive way to calculate things, and it works just fine. So I will go over the rough kind of high-level overview of how that works. So when the dropdown is open, similar to Popper, they use a very similar method of how to magically figure out the position of things when your popped item is rendered and if your UI happens to change, meaning if the initial trigger point, which is this guy, happens to move, I should know how to respond accordingly. So if I open up Performance tab and I click on Record and I click this to open, just going to leave it alone. Stop. You'll see that there's something running. This guy here. There is a tick that runs every request animation frame. That is typically 16.66666 milliseconds, and it's watching for changes. So that is how the UI magically knows how to reposition something, even though um, the the position of the initial trigger may have changed based on UI rendering, or maybe the user is dragging things around. The application or the UI doesn't know. It just knows that, hey, I'm going to pay attention to this trigger. If the trigger happens to change, then do some sort of recalculation to reposition the UI. And also, if there is any kind of like positional calculation, like It was on the bottom, but now I need to render to the top for reasons. That is baked into the calculation as well. So we have, if I take a look at menu container, we have a request animation frame loop right here. Reposition node menus, the cycle. We have the cycle. And the cycle breaks once the menu node is closed because we don't need to calculate that anymore. Um, and the technique I used to help with performance is to memwise things. So I have, where is it? Memwise. There's a lot of things that go on here. Memwise. So I have a style set position style on node, which is setting the X and Y for this box to place itself into the UI. And it accepts a property. It accepts a set of properties in order to figure out the X and the Y and I believe the height. And it should only fire if those properties change. So this using Memwise with props, which is a utility we have within HSDS React, it helps prevent duplicate calculation and duplicate rendering, which is nice. And again, I'm just going over this in a high level stuff. I'm not going to go over the math required to render this. And okay, cycle, update node position, Is this Memwise update set position props? Okay, blah, blah, blah. Here we go. Position props. So this position props thing, I technically didn't need to do this, but I decided to do this just for the sake of debugging. So we have something on position props. This is a callback that is broadcasted with these position properties, top, left position, trigger node, and all these various bits that you can tap into via the state reducer, which is what I'll get into next. And that's it. This just repositions the menu in the UI. And there is some logic here that determines whether or not the menu should drop up or down. And the logic is, and this is what I decided, is by default, the menu was dropping down. But if you specify it to drop up, it will always drop up. I'm going to cap the calculations there. Otherwise, it gets too complicated and trying to figure out opposite directions and all that kind of stuff. So down is primary, up is secondary. Unless you specify up, then up is now primary. And when it's dropping down, if there is a chance that the menu will get cut off by the browser window, like so, if I'm around here, drop up instead. So that's what happens. However, if there's a chance that now we got to run the calculation twice. If I'm going to drop down, but the menu needs to drop up because it'll be cut off if it drops down. But if it gets cut off when it drops up, which is, I believe, this case, then go back and drop down instead. Because either way you lose. You lose whether you drop up or you drop down. So it's better to drop down respecting the initial default. And I believe that's what's going to happen. Yeah. So that's what happens. Great. So very, very rough, semi-complicated position calculating for the dropdown. TLDR, request animation frame loop that runs. Memoization happens in order to keep things performant. And the dropdown will go up or down depending on what you specify. Defaults to down, but if you say drop up, then it'll always drop up. And dropping up or down is calculated on render when the menu is injected onto the screen and is positioned, or rather, the microsecond that the menu is rendered, and then math is done on the trigger mechanism to figure out the X and Y and also the offset and to figure out where the menu needs to go. With those numbers, we can then determine whether or not the menu should drop up or down and then do the calculations that way. And then this happens every single 16 milliseconds or so, as you can see from this tick here. So I mentioned state reducer. State reducer is a really, really cool callback that's built into Dropdown v2. And this was heavily inspired by the work done within Downshift And more specifically, this Ken C. Dots article talking about the state reducer. So what that is inside of Dropdown v2, state reducer, cool. Yeah, powerful, handy feature. I agree. So inside of Dropdown v2, there is basically a Redux store that's happening with actions and reducers and types and so on. Reducer. Under the hood, it's using Redux, which is our kind of slimmed down version of Redux built specifically for libraries, but that's not that important. And what happens is once the next state is calculated, it'll then run through a uh, a callback called a state reducer that the user can then tap into. And it provides you with the next state and also the action that was used to trigger that state change. So you, as a user, consuming the dropdown, you have complete influence in terms of how and when you want that state to be updated. So for this very simple example, this dropdown state reducer example, all I'm doing is tapping into state reducer and just logging the state and also the action. You can see here. So any single time the dropdown changes its state or is about to change its state, you can see things are being logged here. And you can see the dropdown state changes very often. That's just because the item that's being focused is tracked and everything is tracked. So if I check out this action here, we can see that the next index that needs to focus is number 3, the item number 3, and also the interaction type is a mouse. So the dropdown actually tracks whether the the device that interacted with the dropdown is a mouse or a keyboard, which is important for arrow movements and so on. Very intense stuff. And here we can see the state. The state is gigantic for a component. Like I mentioned before, the dropdown is a beast of a component. Um, so yeah, so that is the state reducer. Very, very cool. Awesome for debugging, and then also incredibly useful for people to extend and customize a dropdown to however it is they want. Let's see. So now we have the state reducer, we have the position calculation stuff. Now we're going to talk about the actual menu and the items themselves. So inside a menu container, it does a thing where it tries to figure out if your items have groups because it supports group rendering. So I have a flat dropdown that looks like this, and I also have groups that looks like this, where it's divided between group 1, group 2, and also this idea of dividers. So in previous libraries like Bootstrap or whatever, the way that you would inject a divider is to basically have a presentational empty li with a class of divider or something, and then you get your visual divider. For Dropdown v2, how do you add dividers? Let me see if this feels good, because it's been a while. Divider. Ah, yes. So you have an array of items, and then the items, the shape accepts various things. The thing that Dropdown pays attention to is value and label, very similar to what you would get from a select with those options. So if your type happens to be divider, without anything else, it can just be divider. Then Dropdown v2 knows that it needs to render a divider. That's basically it. And this is really tricky for those of you who have built dropdowns with keyboard support before. Run into this real fast. So if you wanted to do up down on dropdown items, let's pretend every single child item of the menu. Fine, I can do a tab index on it or whatever, and then I can do up downs on it. You need to be able to somehow skip items that are not hoverable or focusable. That includes dividers, disabled items, group/group titles, headers. So the dropdown needs to be able to do that somehow. So I'm here, I press down, 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 down. And if I press down one more time, The divider should not be highlighted. Instead, it should be gerund. This seems like a very simple thing, but I ran into some of these issues multiple times. So, so because this is dropdown v2, there was dropdown v1, which this is replacing, thank goodness. And I remember this being a thing that I ran into during dropdown v1 development. The very simple way to go about doing this is to basically make your selectable items like an anchor tag or something. And with that, you get default and also a href of pound or whatever it is. And with that, you get a default browser handling of tabs, not necessarily up downs, but tabs at least, so that any non-anchor tag things will get skipped when you press tab and shift tab. But we want our dropdown to be super robust, so we need to support up downs, and the item can't necessarily be an li or sorry, an anchor tag, because there might be a chance where you'll have an anchor tag within your item for reasons. So we want dropdown to be able to be flexible enough to support that. So how does dropdown figure out which item to tab into? So this is a very, very important mechanism built into dropdown that no one will ever see. So I have my dropdown. I have 8 items. So if I check out the state, inside the state, you'll see something called an index map. What that is it, for every single tabable item inside of dropdown, it'll create a map that maps its index location to the ID that it's associated with. And internally, that's how dropdown knows how to reference one to the other. When you hit next item via a mouse hover or a keyboard down or whatever it is, it'll look through that map, find the specific ID, and then find that ID within the DOM with one of these data attribute properties, I believe. No, here we go. It'll not find the ID, rather, find the index. Um, and this has an index, tab index, something index, path. That's it. Sorry, it's been a while. So path. There is a very special data attribute within dropdown called path. And that is the one that the index map is mapped to figure out wherever it is it needs to go. And right now it's flat, so it's not too impressive. But if I check out a nested one, hopefully we can see without it collapsing, right? Also, this is another thing where the dropdown needs to stay open if you move your mouse away. Reasons. So if I take a look at this map, you will see that for nested items, we have something else. 0.1, 0.2, 0.3. So the relationship of how that works is if I had every one of these at the root level is a flat 0 to n. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. And if the particular dropdown item has nested items, this is where nesting gets really tricky, then how I've decided to create the map is, in the case of 0 here, if I have a nested dropdown for 0, then the first item will be 0.0, 0.1, 0.2, and so on. And here we have 0, 1, 2, 3, 4, 5. 5. So this first one will be 0, trying to point, 0.5.0. And these numbers are completely unique. And once you understand that system, it's very simple to figure out which index you need to highlight within a nested kind of sequence. And you're able to find those things really simply. And then that has nothing to do with drop down, up, down, left, right direction. It's just a data relationship kind of thing. So with that, that's how the drop down is able to figure out the items that it needs to track and take care of. So we have an internal index map, which is really cool. And really, yeah, it's really intense to figure that out. So now that we understand state reducer, the menu, and then also things like concepts of groups and dividers and how they skip when you do up, down, and mouse overs and so on, um, we can take a look at this real fast. So when the drop-down items render within menu container, render items, render menu items, right? I'm not going to get into loading or empty, but there's that stuff built in. So if there are groups, then the item data structure needs to be remapped slightly to be able to handle group rendering. And that is just to inject a title and also some sort of chunking between the two groups. Otherwise, render the items. And the items, it just maps through all the items and renders them with this very special get items prop method. I'll get into this one. So get item props. This was also inspired by Downshift. And what this is in Downshift, inside of their render property, their render function rather, they provide you with a lot of methods and various data things that you can get to render your custom dropdown. And these, I believe you get items here. Get item props, no, they don't do anything with the item, but get item props. When you give it a specific key or whatever it is, it'll then return for you the enhanced props for that item. And that's how it knows how to handle keyboard interactions and so on like that. So Dropdown V2 does the exact same thing, except get item props is built in to the menu container and all this kind of stuff. That way you as a user, you don't have to fiddle with any of this. You can, if you want to. There is a render prop um, ability, just like Downshift, where it exposes all of these guys for you to tap into to render custom things. But by default, it doesn't. You don't need to do that, and all that stuff is handled internally. So that's what the get item props is. Very important to the rendering of dropdowns and dropdown items. So that's the groups, and we have items. Taking a look at menu real fast. Menu doesn't really do anything. It's just a UI wrapper that renders children. Um, the only thing that menu does that's kind of fancy is scroll locking. So scroll locking is basically means if I scroll up and down and I scroll beyond a certain point, so I'm going to jump to here, this scroll lock example. So if I'm scrolling here, we have Buddy the elf, and once I'm down at this point, if I try to continue to scroll down, it doesn't work. But if I'm here, not locked, and if I'm down here and I try to scroll down again, then the browser will then shift its scroll priority to another element, and that is the overall wrapper. So for certain UIs, you want the scroll to be locked, typically in dropdowns, modals, popovers, tooltip, things like that. So by default, dropdown has scroll locking built in, which can be enabled and disabled by properties, I hope. Yeah, with scroll lock. Yeah, so a lot of Boolean properties attached to the drop-down component, allowing you to enable or disable certain things based on your fancy. Um, so that is menu. And last, we have item. Item is very complicated. And the reason for that is this is the thing that is rendering sub menus for nesting purposes. So item is responsible for doing that. So it needs to figure out whether or not there are sub items and then render the sub menu and then recursively render items. And now this recurses until all of your items have been rendered. And let's see. And in addition to that, item also needs to provide, where is it nested? It also needs to provide the sub menu with a trigger. So how the drop downs work and their positioning and so on is that you have a trigger and then you have your UI, your menu, your whatever it is. And for the positioning to work, you need to know the trigger DOM node, and also the XY of where that DOM node is located in order to do math against it to calculate the eventual menu position. And because this is nested, and because the responsibility of rendering that is built into the item, therefore the item needs to provide the trigger node, which is this, for its submenu, cursing all the way down through the tree until all of the submenus can render like so. And yeah, that is very complicated stuff. Again, things that you don't need to think about because it's built in to the drop-down item component, and also some of that is facilitated via the get item props method that's built into dropdown. So with that, with all those pieces, all that math, all that stuff, we have our base dropdown component, which we can then create something like a combo box. So if I take a look at this combo box component, it's still quite large, I would say, but it's not as large as it would be if dropdown didn't exist. Dropdown, I don't know how many lines dropdown is. 4,000, I don't know, something insane. Um, but since all of that functionality is living there inside of my combo box, all I need to do is focus on rendering the actual combo box UI. So here you can see I'm using dropdown and using the render properties of the dropdown to render a card, maybe some sort of header UI, some input that can control the dropdown, and also the enhanced menu UI, and also the items, render items. What is this? Render items. It's accepting dropdown props. Here we go. Render items. Yes. So like I mentioned, similar to downshift, inside of dropdown, it gives you a couple of properties inside the render method. And I'm going to just basically tap into that and use that to render the items, because the responsibility of rendering items isn't necessarily built into combo box. It needs to be forwarded to dropdown to be able to handle that. So we have this here to handle that. Combo box, its responsibility is searching and filtering items. So we have a combo box right here. We have items, we have groups, and we have dividers. Why not? Up and down work just like as you expect, which is great. Also tabbing. Whoops. Oh no, tabbing does not work in combo box. Tabbing is considered to be a different thing. That is intentional because I believe that's how it's handled in our application right now, and also the typical way that you would handle combo boxes in general. I don't know if that's something that you can override. I think this was like an opinionated thing that we built into combo box. Yes, you can't override that. Okay, fine. That's fine. So if I check out the state reducer for combo box, again, state reducer, really cool thing, taps into state, and here I'm just going to console log stuff. So for every single key that I'm typing into combo box, you can see that inside the dropdown, it was intentionally built to support combo boxes, which is why it's aware of this input value thing. Yeah, D and so on, and it helps track the input values that you can then use to filter against items within the combo box slash dropdown. And combo box has a really cool thing where it's similar to state reducer, if I can remember this. It's similar to state reducer. Where did it go? On change? There is a filter property. Filter search results. It does a thing, and then this is really important. I need to find this. Close custom filter. That's it. So what custom filter does, do I have an example? No, I don't. Custom filter works very similar to the state reducer within dropdown, where the combo box will do its filtering mechanism, will have its items, and you before it renders out, you as a user can tap into that to change how you want the UI to render given a particular search term or a scenario. So it makes it very simple to integrate into existing systems to manipulate or to fine tune and tweak the behavior of something like a combo box without having to write much code, which is great. So we have our combo box. We can now officially go into auto dropdown. What auto dropdown is it's a dropdown that renders a combo box after it has a certain amount of items. So, and then you can set the limit as well. So here I have a limit of, let's say, 8. Crap, 8. So because the limit is 8, after more than 8 items appear, it'll render a combo box instead, making it searchable. So these are just implementation details. No one really needs to know about it. The TLDR is, hey, I want to make my dropdown searchable after a certain amount of items. That's what auto dropdown is. And auto dropdown is a thing that we start using everywhere within the application and so on, because it's just a very handy kind of built-in feature where if you have a lot of items and hey, by default, um, after say 15 items, make it searchable. And because this is using Combo Box, and because Combo Box is using Dropdown, it has all the niceties that are built into Dropdown, including keyboard support, nesting, grouping, dividers, disabled items, and so on and so on. And that is, I guess, the anatomy of dropdowns, combo boxes, auto dropdowns, and all that stuff within HSDS React. Very complicated stuff going on. Basically, an application and a half that happens to be a tiny component that lives within a component library within our system. Um, Hopefully, you found this deep dive and also the part one deep dive helpful in learning Dropdown V2 and just how to think about components or really complicated components in general to make it extensible, flexible, feature packed, very easy to use for the user. And yeah, this was Q. Hopefully you have a great day, and I'll catch you later. Bye.